of all, there's two things that we need to be able to do. All right, we're continuing with 1-6. All right, we're solving compound and absolute value inequalities. I'm just going to put and absolute for sure. Okay? Automatically, what word catches your attention that is going to tell you what type of inequality this is? Or. Okay? So automatically, we're going to be solving for two different inequalities. This is the first one we're going to solve. One of them is literally already solved for us. One of them, it says all the values of C that are less than 0. Could we graph that if we wanted to right now and get it done with? All right, how do we do that? Go to 0. What am I going to do next?
It's not going to be filled.
It's not going to be filled in. It's going to be empty, like open, right? And where are we going to shade on this particular one? To the left. So guess what? We're like halfway there. Oh, that's a horrible shade.
Wait, so
Good.
we're starting off from 0
Because it says C is less than 0.
So we're always going to go on there and be a
Correct. Because we've already solved for C. It's already solved for us, so we just start where C is less than 0. We're not going to include the 0. Okay? For example, if this right here had an equal to sign, then I would fill it in. But it's not, so. Okay. So this one's already done, so I didn't have to solve it. It was already finished, completed. Yeah. Over here, though, I do have to solve. So what would be the solve for C on this one? What's something you think would be the logical first step? -1 all the way across. -1 and -1. Okay? So these right here, these are called, what are those called? +1 and -1? What's the vocabulary? Additive inverse. Good. Alright? So here's what we have left. We have a 2 and a C. Then we have what? We have a greater than and a 4. That's right. Divide both sides by 2. The last step. Whenever you've isolated the C just by itself. Well, this is the first problem today, so hopefully by the end you'll feel better. So we divide both sides by 2, and C is greater than 2. So that's another answer, right? So what are we going to do over here? We're going to put another empty, right? You don't fill it in, you just leave it empty. Because what does that mean? It means we don't include. Not included. So right now 2 is very sad because it's not part of the problem. Correct. We go to the right. Now, this is the correct graph, but what type of notation am I going to require you to do on your test tomorrow? Said, what type of notation am I going to require you to do on the test? That's right, set builder notation. So here's how it works. We know it's going to be an OR statement, correct? So we say the set of all C values such that C is less than 0. So always start kind of with the one that's on the left-hand side. Then you write the word OR. C is greater than 2. So the one that's going on the left, Garrett, you put on the left-hand side. The one that's going to the right, Garrett, you put on the right-hand side. All right? This is the part where sometimes students, they're not sure. They're not as sure of themselves. They can graph it, but then once they put it in set builder notation, that's where they pause. Notice, all answers that have the word OR in them, you put OR. If it's AND, you don't write the word AND. That's what we're going to do out of my assembly. All right, any questions? Now, on this problem, apparently I didn't do a very good job of making a space right here, okay? It's not supposed to be 11.8. It's supposed to start out with the number 8. So I apologize. What I would like you to do, though, is make sure you're aware of where your inequality signs are, okay? And we're going to solve everything on the inside and work our way out. So solve basically from the inside right there. So, if I wanted to get x by itself, what's hanging out next to it? So what are we going to do? Right. So what we're going to do is we're going to subtract 2 from here. But if I subtract 2 from this side of the inequality, I have to do it from this side, but I also have to do it from the other side. So it's kind of a shortcut of solving the problem, all right? Whatever you do to one side, you have to do to the other. So we basically are subtracting 2 all the way across. So who here feels comfortable telling me what the next line is going to look like? Go ahead. Yeah. What kind of symbol? Same symbol, right? What do we have left here? 3x, because these zero out, right? And what do we, same symbol. Very good. So after that one step, we've whittled it down to 6 is less than 3x, which is less than or equal to 21. So who here feels like they could, you've already done your part. Ask them, good job. Anybody else want to take over? Oh, so you're thinking about getting this to 0. Now technically you don't have to. Technically you can just, because you've isolated the variables, you can just divide everything by 3. Okay? So we're going to divide this one, and this one all by 3. Notice, we didn't divide by a negative 3, right? We just divided by a positive 3, so the signs don't flip. All right? So, Cody, you ready? Maybe? Okay. 6 divided by 3. Bam. Sign does not change. 3 divided by 3 is just 1x, right? 21 divided by 3? 7 is correct. All right, good job. Now, you guys see right here how this is pretty much done for you? It's like it's already built. This is an and statement. So if I wanted to write this in set builder notation, I'd say the set of all x values such that, and all I have to do is literally write that whole thing right there, and then do what? Then just close the bracket. So all we have to do is transfer this over. We put the x in the middle, put the 7 there, put the 2 there, and this is your answer, which reads the set of all x values such that x is less than or equal to 7, but greater than 2. Now this graph's going to be a little bit trickier, because what do we have? We have a less than or equal to sign, and we also have a what? X is going to be greater than the 2. So what? When I put it over here at the 2, what kind of circle am I going to put in? Filled in or empty? Empty circle. All right. What about the 7? Filled in. Okay. So make sure, this is very important. Make sure you have one that's empty and one that is filled in. And where are we going to shade? Everywhere in between. Here's why. You see right here how this is an and statement? And is in between. This is the biggest number. That's your max number. This is your smallest number. X is less than or equal to a 7 and greater than a 2. So all your answers have to be basically in the middle of those two numbers, except you can also be equal to the 7. All right, so notice the or statements, where do they go? They go which way? To the left and to the right. That's why I use the word or. This is an and statement. Where are they going to be? In the middle. Now that's a great question. How do you know? Look how this one's already set up. You see the word or in here. All right, go back. What does that say? Here's your hand. You don't see the word or. Okay?
So, and we are.
Absolutely. Okay. All right. Now we're going to go to the back. So right here now we have some clues here. All right. I want you guys to write some clues down, and you can put this in your journal later. Anytime you're dealing with an absolute value inequality, and you see the absolute value of a number is less than a number, you know you're going to eventually finish with an and statement. You see how A is in between the B's? If it says the absolute value of A is greater than B, you know you're going to be dealing with an or statement. So every single one of these, what I want us to do right now is let's put an arrow next to the symbol and label it now, whether it's going to be an and than, it's going to be in and. If it says greater than, it's going to be in or. So I'm going to zoom out real quick. All right, we'll go back to this page. I'll zoom out right here. I think that's pretty much all of them, right? Okay. On your page, all we got to do, it's really easy. We're just going to label, right now we're just going to label and or. What is that one? Or, because it's what? Greater than. What's this one here? So we're going to end up with an and statement. Okay, how about this one here? And, very good. Labeled. That's going to be an and statement. What about this one? Or. Okay, this one? And. All right, here we go. Right here, it says, if the absolute value of A is less than B, then you're going to be left with A in the middle between two numbers. This is referred to as an and type of compound inequality. Okay? If absolute value of A is greater than B, then it says A will be greater than B, or A will be what? Less than a negative B. All right? So what we did was we kind of pre-marked everything. Now, when we went back to solving absolute value equations, what are the two answers that would work inside of this absolute value equation? Two answers. What answers? Absolute value of what number could equal an 8? Negative 8 could work. Because what is the value of, what's the absolute value of negative 8? 8. The other answer that could work is in 8. Here's what I'm saying. If you plug in an 8 or you plug in a negative 8, the absolute value of an 8 or a negative 8 will still be 8. So the solution set would be a negative 8, comma 8. And this is how you solve not absolute value inequalities, but absolute value equations. Okay? How many answers did we have? 2. So if we had 2 answers for this one, how many answers are we going to have for this one? 2. So we have to separate them into 2 inequalities. One of the inequalities is very easy. It's just x minus 8 is greater than or equal to 3. Now, pause and look at that and see if that makes sense. What's the positive value of x minus 8? Greater than or equal to a 3. That's the easy one. Okay? Look at the next one. This expression right here, x minus 8, right there, could also be not just a 3, we could change it to a, this is a positive 3, what could this also be? Negative 3. But if I put a negative 3, what's going to happen to the inequality sign if I apply a negative? It's going to flip. So it goes from greater than or equal to less than or equal to. So the questions I want you guys to ask yourself is this. What changes? So what changes here? All right? The sign, and that becomes a negative, and the sign changes.
Okay, but when we were splitting up, then before we would change the x. Like, okay, so you know how that x is sign is.
All right, so this one is the easy one. It's basically just this expression could be greater than or equal to 3. Then we had to change it. This expression, the x minus 8, would be less than or equal to a negative 3. We had to change this because we applied the negative to the 3. And in inequalities, whenever you apply a negative, what happens to the sign? You have to flip it. Okay? Now, this is not a very difficult problem to solve. Nor is this one. Both of them literally only have one step. What's the only step that you would need to solve this? Add 8 all the way across. That's all you have to do. Add 8 all the way across. So what do we have here? What do we have left? We have an x, correct? This zeroes out. This is greater than or equal to an 11. Here we have x is less than or equal to a 5.